So we've talked about the first derivative. Now let's look at the second derivative, which is simply when we just differentiate it again. So it's the rate of change of the first derivative. So the symbols we use for that, well, y, but now we put two dashes, so y double dash, f double dash x, d2 of the function we're differentiating, dx2. Right? So d2 is not squared, it's just d2 dx2, or d2y dx2. Again, it's not squared. We're not squaring the derivative, you're differentiating a second time. Start with a very simple one, 3x squared plus x plus 2. We find our first derivative, 6x plus 1. Differentiate it again, we get our second derivative. Something a little bit more involved. Square root of x squared plus 3. Okay. Going to have to put that into index form in order to do this. And we'll use our chain rule anarchy. Bring down the power. Bring down the power, lower the power. Diff the inside, we get 2x, and there it is factorised. We get x squared plus 3 to the minus a half. Now normally I'd probably return that to third form, but I'm going to find the second derivative, so it's more useful to be in index form. But now I'm going to have to use a product rule, because I've got a function of x times a function of x. Write down the first, x, diff the second, but when I differentiate the second, I'm going to have to use the chain rule, so bring down the power, lower the power, diff the inside, plus, write down the second, diff the first. Well, that's a nice easy one. Differentiate x, you get 1. There's all sorts of factorising that will happen with this one. We have common factors there of x squared plus 3. You always factorise out the lowest power, so minus 3 on 2 is what we pull out, leaving me with minus x squared, but also x squared plus 3. So I get 3 outside of x squared plus 3 to the minus 3 on 2. Now I'm going to return it to third form, so I get 3 over x squared plus 3 root x squared plus 3. And there's our second derivative. Okay.